All right. Hey guys, Mrs. O'Donnell here. For better or worse, this is the last time I'm going to try this recording. I'm trying out some new stuff today because I'm not used to teaching online using these tools. So I'm going to do my best, so please bear with me. I miss you guys. I hope you are all staying home and safe and healthy. And I'm bummed that I'm not going to get to see you for the rest of the month. But we'll just kind of do what we can to forge ahead. So let's see here. Here are our goals for today. I went ahead and posted this agenda. It's just kind of an outline or a suggestion of what to work on each day. Please come to my office hours if you have questions, or email me with questions. Do not hesitate to email me. We can set, if you can't make it to my office hours, we can set up a different time for you to come, or time to meet. Okay, so we're diving into probability and statistics. So here's just a quick breakdown of different types, different ways that we can display our data. So the whole reason that we have statistics is so that we can make objective decisions by looking at facts. So we're not just making decisions based on opinion or on past experience, but we're really founding our thoughts and our ideas in facts. Unfortunately, there's a lot of ways to manipulate the facts and manipulate the data. So you have to be well versed in the different ways that data can be displayed to you. And you may recognize this as especially important right now with all that we have going on. I'm sure you guys have seen some scary statistics and some strange statistics floating around the internet. And if there's anything that you see that you're just not sure about, please don't hesitate to reach out to me and ask, hey, Mrs. O'Donnell, is this legitimate? Is this, a reasonable source? And we'll figure it out together, okay? Go ahead and pause this video at this point, take a minute, look through, read the different descriptions of the data displays and what they do. If you want to jot some notes, you could do that as well. Again, this is a cool See, Notice, and Wonder. If you'd like to participate in the See, Notice, Wonder, go ahead and pause the video here, check it out, and then come on back and we'll keep moving on. All right, next we've got just some key features of a histogram. So the big thing that I really want to point out to you guys that makes a histogram different than just a regular bar chart is this idea of bins. So your bars in a histogram have to be touching, but they're never overlapping. So basically they're operating on this interval, and they have to be equal intervals. And we call those equal intervals classes or bins. I like the word bin better than class for some reason. I don't know. So for example, this first bar would be in the bin that's represented all of the data between 0 and 19, right? All the data between 0 and 20, not including 20. And then the next bin would be from 20 to 39. The next bin, which doesn't have any data in it, would be from 40 to 59. The next one, which has a little bit of data, is between 60 and 79. Then we've got 80 to 99, 100 to 119, and so on and so forth. And that's really what differentiates a histogram from a bar graph or a bar chart, because a regular bar chart does not have to have bars that touch. It does not have to operate with bins. All right, let's see here. Let me erase my screen if I can. If it will let me. It's not going to let me. Oh my gosh. All right, so another way, data and statistics is all about bringing your awareness to a situation, right? The data didn't change, just the way you're looking at it changes. So here we've got like our big list of data, then we represented it using a histogram. Now we're representing the data using what's called a 5-number summary, and then we use that 5-number summary to re-represent the data using a box and whisker plots. These are all different representations of the same data. Some tell us more than others, and just depending on the kind of data that you're looking at, may change what representation that you want to use. Or maybe you want to use multiple representations so that you can really think through the entire scope of whatever the situation may be. All right, so in order to create a box and whisker plot, you need to be able to find your median. And that takes us to our measures of center, which are mean, median, and mode. And hopefully these are not anything new for you guys, but we're just going to kind of do a quick review of them. So the mean of a numerical data set is the sum of the data divided by the number of data values, right? And we use this X bar to find that, right? So you add up all the data and then you divide by however many data values you had. Right, so here we'd add up each individual, 16.5 plus 8.75 plus 8.65 plus 9.1 plus 8.25 plus 8.45 plus 8.25 plus 9.25, and then we would divide by 8 because there are 8 individual data values. Okay, the median is our middle number. So in order to find the median, you have to organize your data from lowest to highest, and then sort of count to the middle. If you have an even data set, like we happen to have right here, you have to take those 2 middle values and average them to find your true median. And then the last measure of center is mode. And this is the data that's occurring most often. And this MO really helps me. MO in mode, MO in most often. Okay, so right now, if you want to give yourself a challenge, go ahead and pause the video and find the mean, median, and mode of the student's hourly wages. Okay, so if you're coming back, that's great. If you never left, that's fine too. So now we're going to get our answers to the mean, median, and mode. Another way that you could do this is using your calculator, just like we calculated our linear regression by using that stat button and then entering that list 1 or L1. You can do that, and then when you go over to the calculate menu, you can use that one variable statistics. So it's the very first menu in your stat menu, or calculate stat calc, one variable statistics. So your X bar is 9.65. Your median is 8.7. And your mode, or your number that's occurring most often, we see right here 8.25 is our mode. It's, I think, the only number that repeats. Okay, so give yourself a little pat on the back if you got all of those right. If you didn't, make sure you take a minute and think about what went wrong and how can you change it for next time. Okay. The last thing that we really want to think about with mean, median, and mode is which measure of center is going to best represent the given data. Okay, and sometimes that's kind of hard to see. It might be a little easier to see if our data was plotted or we had a scatter plot, or even just having the data listed out, which you would have done to find your median if you're doing it by hand, might help. In this case, the median is actually our best measure of center. All right, so let's see what else we've got. We've got some key vocabulary here. Data sets can have outliers. Outliers can really mess up or skew your data, so you want to be aware if you have any outliers. You can have a range. You want to look for your range of your data set, which is the difference of the greatest value and the least value. And then your standard deviation, which is how far your data value is from the mean, from that average. And I put the formula there. You do not need to memorize that formula. All right, now we've got our box and whisker plot. So this is what you guys started working with yesterday a little bit. So if we're looking at our box and whisker plot, your box and whisker plot takes your data and chunks it into 4 equal groups. So it quarters it, right? So your first whisker represents 25% of your data. This section of your box between your first quartile and your median or your second quartile is 25% of your box. Then between Q2 and Q3 is 25% of your box. And this last whisker here between Q3 and your highest, your maximum, or your greatest value is also 25% of your data. Okay. And like we said on the previous page, you can use your 2 slides ago, I think, you can use your 5-number summary. You can use technology to find this. So again, you can type in your data list to your TI-84 using that stat L1. And then you would go to calculate one variable statistics to get your 5-number summary. Okay. And that will be how you plot your box and whisker plot. Okay, so at this point, how do you create a box and whisker plot? So here's how you create it, right? First thing you have to do, you take your data set and you have to put it in order, right? So you've got your lower half, your upper half, you find your median, which is right here at 25. We know our least value, that's the easiest one, isn't it? Your quartile, your first quartile, right? So that's the median between your lowest value and your median, right? So that's going to be 23. So you're averaging the 22 and 24 to get 23. And then you do the same thing up here. You kind of treat it as like a subset of your data set, right? So you're going to find the median between your median and your greatest value, which it looks like is 29 in this case. So you added 28 plus 30, divide by 2 to get 29. Then you've got your number line. So your box and whisker plot always has to be across from a number line, always has to be next to a number line. Okay, and then you just start plotting your 5-number summary, right? So our minimum was at 18. Our first quartile was at 23, so I'm just going to put a dot right there. The median was at 25. The third quartile was at 29. And the greatest value is at 30. So I know that my greatest value to Q3, which is right here, and my least value or my minimum to Q1 is right there. Those are my whiskers. And then I can create a box to represent, this is called my interquartile range, my IQR. So between Q1 and Q3 is my IQR. Sometimes they'll ask you to actually calculate that range, and you're just subtracting. Q3 minus Q1 gives you your IQR. Q3 minus Q1 is the IQR. Okay? Okay, so I see we're running a little short on time, so I just want to get to this last slide since I've got about 1 minute left. On this last slide, we're just looking at correlation coefficient again. Just flash back to that linear regression stuff we did back in probably beginning of quarter 2. And remind yourself so just remind yourself that correlation coefficient is showing you how tightly correlated the data points are to that line, that model, right? So if you have a perfect negative correlation, your R value would be -1. No correlation, your R value is 0. Up to a strong or to a perfect positive correlation, your R value would be +1. Okay. I think that's about all the time I have for you guys. So don't forget to do your Google form, and I will see you tomorrow.